In this video we're going to look at special expansions of double brackets. So in this case we'll start looking at something called the difference of two squares. Okay, so I've written the two brackets down. We've got a double bracket, so we can see that this bracket is multiplied by this bracket. We can also see that it really only contains two terms. We've got A here, and then B here and B here. But the B's are opposite signs of each other. And obviously, if we're going to expand that, we're going to look for a pattern. So let's use FOIL to expand. So we do the first, A times A, which is A squared. Let's do the outer, A times minus B. Remember, this negative belongs to the B, so it's minus AB. Then we multiply the inner, so B times A, put it in alphabetical order, AB. And then finally the last term, which is positive B multiplied by negative B, so that's negative B squared. Now let's do as we usually do and collect together the like terms. What we see is the two middle terms are identical and opposite sides of each other, so they cancel each other out, leaving us with A squared minus B squared. So the result is actually just the first term of the bracket squared minus the second term of the bracket squared. Let's look at it if the bracket's the other way around. It shouldn't make a difference, but let's just check. So we've this time put the negative first. Again, we're going to use FOIL. So without using the red lines now, A times A is A squared, multiplied by plus A times B, which is the outer term. The inner term is minus AB, and then finally minus B squared, leaving us with these two middle terms cancelled out. So it's just A squared minus B squared. Change that, made a little mistake, there we go. So we've got the same result. So generally what we're saying is the difference of two squares. When you see two double brackets together like this with opposite signs, you can take the first term, square it, and take away the second term and square it. Okay, let's go on and do some examples. So you can see here that I've got x minus 4 in the first bracket multiplied by x plus 4 in the second bracket. The two brackets contain the same terms, just one's a negative and one's a positive. So the rule says I can just multiply the first together, the first term, and square it, so it's x squared. Take away the second term, square it, 16. So 4 squared is 16. And let's go on to B. As again, we've got 5a and 5a here, and then the b's are the opposite signs, so we know it's the difference of two squares. So you just square the first term, so 5a squared gives us 25a squared. And then we square the second term, which is b, so it's just minus b squared. And finally, my third example. So again, we can see that we've got the difference of two squares, same terms, just of opposite signs. So we just square the first term. I'll write it out as 3x squared first, minus the second term squared. Second term is 4y, so we squared that. So we square each term. 3 squared is 9, 9x squared for the first, and then 4 squared is 16, 16y squared to give you the answer. Now, the binomial products in which the two factors are the same are called perfect squares. So I'll do one generally with a and b. So a plus b all squared is, if I were to expand that, we know that anything squared is that times by itself. So if I write that out, and now I can use FOIL to expand, we get a times a squared. Sorry, a times a is a squared, plus the outer, which is a times b, plus the inner, which is b times a. So that's going to give us ab plus ab. And then the last term is just b times b, which is b squared. Now, if we look at each of these, we can see that the first term is just the first term in the bracket squared. These two here are both a product of the first and the second term. And then this last term is the second term squared. Okay, so this now simplifies. We can collect together the middle terms to give us a squared plus 2ab plus b squared. So let's use this general rule here to expand these two. So part A is a plus 3 all squared. So I need to use the first term and square it. Let's write in black, x squared, plus the product of the two. So that would be 3x plus 3x, which is 6x. And then lastly, the second term squared, which is 9. Let's do it over here again. So the first term squared is 5x squared, so I'll write that down like so, plus 2 lots of the product of 5x times 1, which is just 5x, plus the last term squared, which is just 1 squared. So writing that gives us fully 25x squared plus 10x plus 1.